Hello friends, welcome to my channel. So today we are going to talk about Kubernetes Fundamentals, wherein we'll look at what is pod, Replicaset and deployment. And after this tutorial, you will be clear on differentiation between pod, Replicaset and deployment. And they are interrelated, but how we'll talk more on when we are doing it. And we cover a bit of theory just to make our concept clear, and then we'll hop into actual doing it, and that's when we solidify what we learned. Right? So pod, Replicaset and deployment. Let's get started. So first, we look at pod, which is the smallest deployable units of computing. Pod is a group of one or more containers with shared storage network resources and a specification for how to run the containers. So pod is having possibility of having more than one container. Usually for application container, we'll have only one container in pod, but there could be multiple containers sitting in the same pod. But pod cannot span across nodes. So if you see, one pod can be sitting on only one node. It cannot span across node, and that's how you can be clear on how it is sharing storage and network resources, because it's attached to one node, and whatever storage and network resources attached to that node, right, that are accessible to pod. So that's how it is saying this only pod is sitting on one node, and it is sharing storage and network resources. So whatever containers are inside pod, right, they are sharing these resources, right? So that is what first point talks about. Then each pod is meant to run a single instance of a given application. I already talked about this. And the pods natively provide two kinds of shared resources for their constituent container, which is networking and storage. Right, because you can think about this as a one pod having multiple containers sitting on the same node. So that is obviously it is sharing network and storage resources. Container inside pod can communicate through localhost. Right, same thing, like it's sitting on the same node. So what pods have, right? One is a unique IP address, then persistent storage volume. As persistent storage volume is optional, but we can associate that with pod. Then configuration information that determine how a container should run. So what image you want to use for the container, that you can specify when you are specifying pod specs, right? In part of pod spec, and we look at it, there is a something called containers, and you can specify containers and their image, their name, and there are other attributes as well, but that's what it says, like it determines the configuration of your container, and that's what you will have it in pod. Okay, so let's look at the demo for containers, right, and pod. So this is a pod.yaml file. You see, whatever highlighted in blue, right, that is that are the attributes you will see in every pod YAML. So API version, kind, metadata and spec, and it's not only for pod, it is there for most of the resources what you use for Kubernetes. So it is very easy to remember. Wherever you are seeing at pod YAML or Replicaset or deployment, what we are going to do it in the next couple of minutes, you will see that API version, kind, metadata and spec will be there. So API version for this is v1, kind is pod, metadata we are just giving labels to it. So I'll talk about labels, how it is important when it comes to using pod as part of Replicaset and deployment. But label is env is equal to demo, and name for this particular pod is nginx. Specification, I was telling you the specification contains something like container, and here it is an array. Like if you see the dash, which is telling that there could be multiple containers. So for this particular pod, there is only one container with image nginx, and name of that container is nginx itself, right? So this is pod, and now we'll hop on to our actual working lab, and there we'll see how to create this pod. Okay, so I'm connected to control plane. So what I have used is I have used Minikube to create this container cluster. So Minikube usually will be command like this: Minikube, then kubectl, and in later videos we'll get into details about this. But now I just want to show you how to create pod. So get nodes, right? You can see when node is there, right? And what I'll do is, just to make our life easy, I'll just create one alias with mini kubectl, right? So what that gives us is, I can just do like this, right? Okay, so now I have this YAML file already sitting here, and exactly same YAML we just reviewed. So let me see, show you how to create this pod. Okay, so this pod is created, and if I look at pods, right, you will see this nginx pod is there and it is running. So that is how it is. Like, you can create pod, and these are the content of the YAML file, and I can provide this in description, so you yourself can try creating a pod. Now let me just delete the pod. Sorry for that. Delete minus a pod. You can just do kubectl delete pod and pod name. You can do that, and you can even specify YAML file like this. So whatever is content of the YAML file, right, those get deleted. So this is easy way of deleting it. Okay, that was pod for us. So, right, so replica set is something which guarantees that availability of a specified number of identical pods. So that how we use replica set and why we use it is to maintain a stable set of replica pods running at a given point of time. A replica set identifies new pods to acquire by using its selector, and we'll look at what this selector is and what are the fields for replica set. And this will something you should remember. It will really make it easy for you to understand what is replica set. So selector is specifies how to identify pod it can acquire. So how many pods you need, that is what replicas field will tell. Number of pods replica set maintains. Then what is template? Template is pod template to specify pod details including image. So whatever pod we have seen earlier, right? So pod.yaml, I'll tell you how that pod.yaml can be used to create a replica set template, right? This is template, nothing but is a pod definition. So replica set is linked to its pods via the pods metadata.owner references. So owner references I'll talk more when I show you a replica set. But for now, just understand that replica set has like when you see the definition for pod, it will have owner reference, and owner in that case will be replica set. Use of deployment is recommended instead of directly using replica set. So you should know the concept of replica set, but Kubernetes like recommends you to use deployment instead, and we'll see more details what deployment is. But you should definitely know the concept of replica set. So yeah, so let's look at how replica set YAML file looks, right? So as I said, like most of the Kubernetes object will have, YAML file will have this section: API version, kind, metadata, and spec. On right side you can see Replicaset.yaml, and left side it is pod.yaml. Pod.yaml we already looked at. Now let's look at Replicaset.yaml. So if you see, API version is app/v1, kind is replica set, metadata name, this is name given to your replica set, and labels, this is name or this is label given to your replica set. This is not talking about selection criteria as it. In specification you are making sure like you are giving replicas, which is 3 in this case. So what that tells us is it will be provisioning 3 pods as part of the replica set. What is selector? We looked at the field, right? Selector is something selecting which pods will be added to this replica set, or when you create the replica set, what label should be associated with those pods. So matchLabels env demo. So if you see env demo, exactly same is there in your pod. So that pod will be part of this replica set. So selector is telling us we should look at this particular label. Then template, and template is metadata and spec. So if you look at it, it is exactly same what is there in pod. We took metadata and spec, so exactly same copied to template. That's how we are telling replica set use this template and create our pods. So except API version and kind from pod.yaml, everything is flowing into your template. So that is what template is. It's very easy to understand. Okay, so let's go into the lab again And now what we'll do is we'll create replica set. I just want to show you that replica set is exactly same copy paste. Like I didn't change anything. I just want to use exact same version of YAML, so that like we see like what we are learning theoretically is matching to our practice as well. Okay, so key create NSF and replica set. Okay, so replica set is created. Then RS is a short form for replica set. So get RS. So it is showing like demo-rs is created. If you see demo-rs is nothing but the name of the replica set. And if you see pods now, you will see the exact same name as a prefix demo.-rs, and there is some random number or alphanumeric character associated with it, just to have a unique name, but it is using demo-rs as a prefix, right? And if you delete any of this pod, for example, let me delete this pod. So I deleted this pod and I'll do it again. You can see again this pod is gone, first one, but it span new pod, which is this, right? So 4 seconds ago, instead of 57, it is 4 seconds. So whenever you are deleting one pod, it is getting recreated as part of the replica set. That is the advantage of having replica set. And that's when we saw in theory that replica set is nothing but a collection of identical pods. Yeah, so let me show you owner reference section in pod definition and how that is used for maintaining this dependency. Yeah, so this is like kubectl get pod and the pod name, and then you can see our owner reference here, right? So this is how you can see that replica set, which is demo-rs, is specified in pod definition itself, and that is how owner reference is used. Okay, so this replica set is good. So let me just delete it now, replica set. And when you delete replica set, or even if I just do kubectl delete replica set and replica set name, it will delete pods sitting inside that replica set. So now you should not see any pods. Okay, so hope that is clear on replica set. So let's see how replica set is different from deployment. So deployment is declarative updates for pods and replica set. Declarative updates. So you are specifying how you want your replica set and pod to look like when you are creating deployment. Deployment creates replica set and replica set creates pods in the background, right? How replica set creates pod, we have seen it. Now we know that deployment creates replica set. So this is a chain between deployment, replica set and pod. Do not manage replica set owned by a deployment, right? This is very simple to understand. When you are using deployment, let's manage only deployment. Deployment takes care of replica set and pods. So what are the fields for deployment? Again, you need some selector, right? Depends how the creator replica set finds which pods to manage. So again, like it is same like what we have for replica set selector. Then replica set, how many pods replica set want to maintain. Then template, pod template to specify pod details including image. A deployment's rollout is triggered if and only if the deployment's pod template is changed. So for example, you have a deployment, and when that rollout will trigger, right? Whenever you are changing pod template. If you are not changing pod template, there is no reason to redeploy your pods, right? So that is clear from it. A deployment's rollout is triggered if and only if the deployment's pod template is changed. Okay, so let's look at deployment.yaml. So if you see, it is exactly same. Like it's very easy to remember. It is exactly same like replica set. Only change happened is kind. If you see kind on deployment.yaml, we are saying deployment, but everything else is exactly same. So and template, like this is specification for your pod, and it is like directly taken from pod.yaml, which is taking metadata and spec and leaving behind apiVersion and kind, right? So this is deployment. I'll show you how to create a deployment. Let me clear this for now and deployment. So this is exactly same what I have seen it in just now. So this is a deployment, and let me create one, right? Deployment.yaml. So if I do this now, get deployment, you can see demo-deployment is created because that is the name we have given, right? And now get Replicaset. So if you see, Replicaset is prefixed with demo deployment and some number, right? Random alphanumeric. So if I take pods now, this has a prefix exactly right, demo deployment and Replicaset name. If you see, it is exactly same name, that is a prefix, and some random alphanumeric. So the names are derived from deployment as a prefix for Replicaset, and pods are having name prefixed with Replicaset name. So when you are creating manually Replicaset, right, it is exactly same behavior what we can see. And now if you delete one pod, it will just get recreated, because that is anyway it is like a backend, right? It is a Replicaset, nothing different than that. So yeah, so that is how naming convention. And if I delete deployment, this time instead of using that -f and file name, right, let me show you this, directly using delete deployment and name of that deployment. When you are using multiple resources in the same YAML file, right, then if you want to delete complete stack, you can just delete it using YAML file itself. So whatever specified in YAML file, it get deleted. So now let's see one by one. Pods, there is nothing. Replicaset, there is nothing. And deployment, anyway we deleted it. Deployment. Yeah, so everything is clean, and I showed you two ways of deleting it. One is delete -f and then name of that YAML file, and here we just use directly deployment. So this is the difference between pod, Replicaset and deployment. Hope that is clear to you, and you will try it on yourself and let me know how it goes. Hope you learned something new today. If so, please like this video, share, leave your comment so that I know this content is helping you. Don't forget to subscribe, and that's now. Okay, see you again with yet another exciting tutorial about AWS. Keep learning, keep sharing what you learn, and thanks for watching.